Hi students, today we'll solve a very interesting JEE Advanced Level Projectile Motion problem, and I challenge you to solve this question without seeing my solution. And can you get a better solution than mine? It's a challenge. If you get it, do send it to me and please do in the comment section. The problem says that there is an inclined plane of inclination phi, and there is a particle that is released from point A and it reaches point B. There is no friction here, so mu equal to 0. And from the base or from the apex point C, there is a projectile projected with certain velocity such that the projectile also reaches point B. It is given that the length CB is equal to R and the length AC is equal to H. So, if this projectile goes from point C to B at the same time as the particle that is coming along the inclined plane from A to B takes the same time. So, the particle takes what time? TAB. What is the projectile time? TCB. TCB. These two times are equal, that is given. And also given that the particle's velocity at point B and the projectile's velocity at point B are same. So, I will repeat the question. A particle released from the top of the inclined plane, smooth inclined plane, reaches point B at the same time as that of the projectile projected from point C. It takes the same time to reach point B, and both the particles reach point B with the same speed. So, this is the information that is given. So, you can see on the screen, these are the two informations given. From this information, you have to find out what is the angle of inclination of this inclined plane and also what is the angle of projection. Okay. So, those of you who want to try this question, you can pause the video here and try on your own, and those of you who want to continue with the solution, please do. So, the first thing is that what time this particle that is coming along the inclined plane A to B will take. So, for that, let us assume that the AB distance is equal to S. So, this is my assumption. Okay. From Pythagoras theorem, you can easily see that S is equal to how much? It is coming root under h square plus r square. So, S, which is the distance covered, and the particle starts from rest at point A. So, this means that I can use the kinematics equation S equal to ut plus half at square. And what is the acceleration along the inclined plane? It is g sin phi. So, half into g sin phi into t square. So, what is the time taken by this projectile? T square is equal to 2s by g sin phi. Now, from the diagram you can easily see that what is sin phi? Sin phi is h by s, it is perpendicular by hypotenuse. So, what I can do here, that I will replace sin phi by h by s, that means s becomes s square. Now, what is your s square? S square from Pythagoras theorem is h square plus r square, right. So, this is t square. Let me write this as equation 1. Now, in this same time, the projectile has come from point C to point B. Now, what is the time of flight formula? The time of flight formula is 2uy by g. What is uy? It is the initial velocity's y component. So, suppose if this projectile is projected with velocity u, then what is the y component of u? It is uy. And what is the x component of u? It is the ux. So, I can write time of flight t is equal to 2uy by g. And also I can write by using the tunnel vision ux into t is equal to r, right. So, I am getting uy is equal to how much? gt by 2, and what is ux? Ux is coming as r by t. See, the target is that because I have to find out the phi, the angle phi. So, what I am trying to do is that I am trying to get an equation involving h and r. So, how to do that? I got the t square. So, somehow I have to relate this. So, what I can see here is that ux square plus uy square will be how much? It is u square, because the resultant of ux and uy is u. So, u square is equal to ux square, which is gt square g square t square by 4 plus r square by t square. Now, because it is given this condition, the second condition, that the particle's velocity and the projectile's velocities are same. Now from the projectile motion theory, if you project a particle with speed u at the same horizontal level, what will be its speed? Its speed will obviously be from energy conservation. The value will be u, obviously the direction is changed, the velocity will be different, but the speed will be u from energy conservation. Now how to get that particle's velocity which is coming along the inclined plane? So for that, what I can do is that I can use simple energy conservation. So at point A, it was at rest. So what was its energy? mgh. When it has come to point B, its complete energy is kinetic because it has come to the reference frame level. So this means half mv square, here v is the particle's velocity, must be equal to mgh. So if I cancel the mass and cross multiply, I get v square equal to 2gh. But according to the problem, this v square must be equal to u square. It is a projectile's projection velocity, right? And that will be the speed at the point B according to the problem. So instead of u square, I can write here 2gh. And here g square by 4 into t square. Now what is your t square? See this value. So 2 by gh r square plus h square plus r square by t square. So take it as the denominator. So it is coming 2 by r square plus h square, and gh will go at the numerator. So this is equal to 2gh. So I am very near to get an equation involving r and h. To get the complete equation, what I am going to do is that I will divide both sides LHS and RHS with 2gh. So if I divide it by 2gh, I get 1 here. So g and g will cancel. So numerator is 2g. And if I divide by 2gh, so what I am going to get? R square plus h square whole divided by the 4 will stay and h will become h square and 2g will cancel out, right? Plus here I am going to get r square plus 4 divided by 4 r square plus h square. So this is an equation involving r and h. So I am very near to solving it, because suppose if I can find out the ratio of h by r or r by h, I got the angle, because h by r is tan phi and r by h is cot phi. So that's my target. So you can see at both the denominator there is 4. So if I cross multiply this, I'll get an equation, and that equation will be, so if I continue the previous equation here, let me just copy it, this equation, and I'll solve it in the next page. So here is this equation. So to solve this equation, what I am going to do is that I will cross multiply the 4 and I will get r square by h square plus 1 plus r square divided by r square plus h square. My target is to get either r by h or h by r, whichever will be convenient. Now 4 and 1, so I'll take the 1 on the left hand side, this will become 3, and this is now r square by h square plus r square by h square divided by r square by h square plus 1. What I did is that I took h square out and divided. So now I will assume that r square by h square is equal to z. So what I am going to get? I am going to get the equation 3 is equal to z divided by z by z plus 1. So if I solve this, I am going to get z into z plus 1 plus z whole divided by z plus 1. Now cross multiply this. 3z plus 3 is equal to z square plus 2z. So if I do the side change, I am going to get z square minus z minus 3 equal to 0. So this equation obviously cannot be solved by midterm. So what I am going to do, I will use Sridharacharya. So Sridharacharya using, I am going to get 1 plus minus root under, you can see it is 13 divided by 2. Now what is z? Z is r square by h square, which is ratio of positive number. So ratio of positive number cannot be negative. So this means the negative solution 1 minus root 13 by 2 will be rejected. So I am going to get z, which is r square by h square, is equal to how much? 1 plus root 13 divided by 2. So h by r will be how much? The reciprocal of this, which is 2 by 1 plus root 13 and its square root. But from the diagram, if you see, what is your h by r? It is the tan phi, right? So I am going to get tan phi is equal to root under 2 divided by 1 plus root 13. So phi, which is the angle of inclination of the inclined plane, is tan inverse of root under 2 divided by 1 plus root 13. So this is the inclination of the inclined plane. Now how to get the angle of projection? To get the angle of projection, if I stress a little bit on the diagram, I can easily see that ui and ux, the resultant of those two is u. So from simple theory, I can see from the right angle triangle that ui by ux, because rectangles opposite sides are equal, so this will be also ui. Ui by ux will be how much? It is going to be tan theta. So to get tan theta, I will do what? I'll take the ratio of, here theta is the angle of projection, it is ui by ux. Now if you remember, what was your ui? Ui was gt by 2. What is your ux? It is the r by t. So I am getting g by 2r into t square. But what is t square? If you see here, we got t square from equation 1. So this is my t square. Let me copy this thing and paste it here. So g by 2r, and I'll paste that equation. So this is that equation. So instead of t square, I'm going to put that data. So what is this t square? This value, right? So it is coming this. Now g and g will cancel out, 2 and 2 will cancel out. So I'm going to get tan theta, theta is the angle of projection, as r square plus h square whole divided by rh. So this is going to come as r by h plus h by r. But already I got r by h, also h by r. H by r is this, root under 2 divided by 1 plus root 13. So r by h will be the reciprocal of this. So just put this data. So this is going to be r by h. So r by h will be root under 1 plus root 13 by 2 plus root under 2 by 1 plus root 13. So this is coming as root 2 into root under 1 plus root 13, and multiply this 1 plus root 13 plus 2. So this is tan theta. Now what is then theta? Theta is the tan inverse of 3 plus root 13 whole divided by root under 2 into 1 plus root 13. So this is the angle of projection. So I hope you really like this short video, and please do subscribe to my channel. Tata, see you in the next video. Bye bye.